Okay, so let's talk a little bit about heat capacity and energy calculation. So the first thing we need to know is the formula. Q is equals mc delta T. What Q stands for is what we call the heat. Usually it's given in joules. The question could be in kilojoules or just depend, but usually our unit is joules. M stands for the mass, grams. C stands for specific heat. And in your book, you have a table that gives you specific heats for different metals and molecules. And on here, we have change in temperature. And delta T is equals to final temperature minus initial temperature. Okay, so in iLearn, usually your professor gives you the change in temperature in Celsius. And on Alex, you usually have the change in temperature given in Kelvin. Let me just define something here. The units for this guy is joules, grams, Celsius, or we also can say joules, grams, Kelvin, just depending, and the temperature could be Celsius or Kelvin. Okay, so it really doesn't matter if you're dealing with the temperature in Celsius or Kelvin, because the answer will be the same. So let me give you one example here. Suppose I tell you that my initial temperature is equals to 100 Celsius, and my final temperature is equals to 200 Celsius. And I ask you to calculate a delta T, so you do delta T is equals to final minus initial. So the change in temperature will be 100 Celsius. Now let's do the same thing, but converting everything to Kelvin. So my initial temperature in Kelvin would be 100 plus 273, that is 373. And my final temperature would be 200 plus 273, that is 473. If I do the change in temperature now in Kelvin, will be final minus initial, which gives me the change in temperature equals to 100 Celsius, or Kelvin. So really, the change in temperature will be the same. So really doesn't matter if you convert it or not. Just for information on Alex, it'll give you the change in temperature in Kelvin. iLearn and in your book that you use for 101 usually gives the temperature in Celsius. Okay, so now that we understand this is heat, math, specific heat, and change in temperature, we can solve some problems. So let's say the question tells me, I want you to erase the formula. But the question says, how many joules are required to heat 81.3 grams of aluminum from 56 Celsius to 300 Celsius? So, first of all, mass is equals to 83.1 grams. Specific heat of aluminum, it's in a table, it is 0.897 joules grams Celsius. And find the initial temperature given the question is 56 Celsius, and final temperature is equal to 300 Celsius. So what we do, so they ask how many joules are required, so they're asked for Q. So Q is equal to, and then I plug my numbers straightforward in my formula, it would be 83.1 times 0.897 times final minus initial temperature, in parentheses. It is my delta T. So if I do that, it would be 83.1 times 0.897 times parenthesis 300 minus 56 close parenthesis. It will be Q equals to 18,187.9. So joules, or I could just write this because it's a big number, correct in scientific connotation. Q can be 1.82 times 10 to the 4th joules. This is my answer. Now, let's work in another problem. There's really a chem problem that you're gonna see doing your homework and another assignment. Now the question says, if 238 joules are applied to 7.44 grams of water, originally at 25.9 Celsius, what will be the final temperature? So, what is the final temperature? And they gave me 238 kelvins, joules, and mass equals to 7.44 grams. We know that specific heat for water is 4.184 joules on grams Celsius, and the initial temperature here is given by, it is 25.9 Celsius. Okay, so we use our formula, Q is equals mc delta T. So we have Q, we have M, we have C. What we want to find first is the change in temperature. So when you find the change in temperature, then we can figure it out the final temperature, because we know that change in temperature is equals to final minus initial. So first of all, we need to solve our equation so we could have delta T by itself. So Q is equals mc delta T. If I want a delta T by itself, what I do? I divide it by mc both sides. So I know that delta T, or change in temperature, is equals to Q over mc. Now I plug the information the question gave to me. It's really helpful if you write it down. The information on your left side helps me to keep track of everything that I have and helps me to figure it out what I'm supposed to do with all that information. So delta T is equal to 238 divided by my mass, 7.44 times 4.184. You want a parenthesis in the bottom. So if I do that, 238 divided by parenthesis 7.44, that is my mass, times my specific heat for water. And again, the specific heat is given on a table. You will see that the change in temperature is equal to 765. This is the change in temperature. Okay, now I go for the next step, because the question does not end it yet. The question asks me for the final temperature, not the change in temperature. I know that change in temperature is equals to final minus initial. Final temperature minus initial temperature. So I want a final temperature by itself. So I solve my equation again so I could have final temperature by itself. So I add the initial temperature in both sides. And I know that final temperature is equals to the change in temperature plus initial temperature. Now that I have final temperature by itself, I know the initial temperature was 25.9, and I know the change that is 7.65. So I just added to my 7.65, 25.9, which gives me final temperature equals to 33.5 Celsius. And this is my final answer. So when I am dealing with heat, I need to use this formula. Q is equals mc delta T. M is the mass, C is the specific heat, and delta T is the change in temperature. I like to write it down on the left side, everything that I have, all the information the question gave me. In the case here, they gave me Q, M, and C, specific heat. And then I ask myself, well, what is the question asking me to? Is the question asking me for the heat? Is the question asking me for mass? Or for the change in temperature? In the case of this problem, the question was asking me for final temperature. In order to find the final temperature, first I need to find the change in temperature. So I solve my equation for delta T, and I know that if I divide both sides by MC, I ended up having delta T by itself in one side. Q divided by MC. Then I plug my numbers, I found the change in temperature, but I did not end the problem yet because the question did not ask me for the change in temperature. The question was, what was the final temperature? So I know that delta T is equals to final minus initial. I solve my equation for final temperature, and then I plug everything and I figured it out, my final answer.